Hello everyone. Today we are going to discuss one important theorem from the triangles chapters of grade 10. Okay, and that theorem is nothing but 6.1, which is also called as basic proportionality theorem or the Thales theorem. What does it say? If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. That means there is a triangle. So in that triangle, we are going to draw one parallel line. Okay. So when you draw that parallel line, that intersects the other two sides in two distinct points. Okay. And the sides which are divided by that parallel lines are in the same ratio. So that means the other two sides are divided in the same ratio. Let's understand this better by the diagram. Okay. Now see, these are the two major important words. We are drawing a line and we are getting same ratio of sides. Okay, now let us consider there are three different triangles. Okay, we will name all the triangles as ABC only. So this line DE, okay, which is parallel to line BC, that means D is parallel to BC. So as per the statement, we drew one line parallel to one of the side of a triangle, that means we drew D parallel to BC. Okay, so then as per the statement, what's the ratio? AD by DB is equal to AE by EC. Now in case if we draw a parallel line to the other side, that means now the line is parallel, that is D is parallel to BA or ED is parallel to AB. So when I draw like this, the vertex which is opposite to the parallel line, see these two lines are parallel, AB and D are parallel. Opposite to these parallel lines we have C. So what will be the ratio now? How do we take it? CE by EA is equal to CD by DB. Now we draw a parallel line to the other side, that is AC. So D is parallel to AC. So now opposite to this parallel line we have B. The ratio will be BD by DA is equal to BE by EC. This is what we get. So totally three different ways we have drawn the parallel lines, correct? So based on these three different lines, we are going to get the ratio. So which are the ratios? Now if you look into it, see AD by DB, AD by DB equal to AE by EC, the first one. Then C by EA is equal to CD by DB, second one. Then BD by DA is equal to BE by EC. So this is a ratio. So when this happens, when you draw a parallel line to one side of a triangle, right? So this is the parallel line which is drawn to one side of a triangle, and other two sides, that's AB and AC here, CA and CB here, AB and BC here, intersects at two different points, that is D and E. Okay, which divides those sides in the same ratio. That means this is the ratio of those sides. Okay, this is what the theorem means. Okay, let us prove this. Okay, to prove this, we are going to take a help of area concept. Okay, so before that, as per the statement, we will write the given thing, that is in triangle ABC, D parallel to DC. Okay, what do we need to prove here? We need to prove that AD by DB is equal to AE by EC. So AD by DB equal to AE by EC. Okay. So as I told you, we are going to use area concept of a triangle. We need base and height, correct? The bases are going to be the sides of triangle, but there is no perpendicular line, right? So that perpendicular line only we are going to draw. What is that? Draw DP perpendicular to AC and DQ perpendicular to AB. Also join BE and CD. So these are the lines. Okay. Now you can see DP perpendicular to AE and EQ perpendicular to AB. Okay. Then we are going to join BE and CD also. So when you join BE and CD, you can see, right? Okay. Now how we are going to solve this? We will take one side of a triangle first. That means we are going to take AB side first, and AB is going to be the base of the triangles. To take AB as the base of the triangle, we have to choose triangle accordingly. Okay, so let's prove that. Okay, the proof is not that hard. We can work it out. Okay, in the proof, what we are going to do, we are going to take a concept of area of triangle, which is half into base into height. So for that, we have to choose triangle. Okay, see now we can see we have chosen triangle ADE and triangle BDE, where we are considering the base of a triangle as AB. Okay, so if you split this triangle, we are going to get like this. Okay, now see area of triangle AD. So where is AD triangle? AD triangle is this. Okay. Now here half of AD. AD is the base and EQ is the height, because EQ is the line which is perpendicular to AD, correct? So when you rearrange the triangle, we are going to get a shape like this. Okay. It is nothing but the same triangle is drawn tilted. Okay. Now then we are taking triangle BD. Where is BD? BD is this triangle. So its perpendicular is same only, which is EQ. Okay. Why the perpendicular of the triangle is outside the triangle? Because it is an obtuse angle triangle, correct? So what happens when you draw perpendicular? It goes out of the triangle. That means EQ is the common height of both the triangles. So by that way, what happens? You can cancel few things here, right? Half and half we can cancel, and also EQ and EQ we can cancel. So what is left? So we are going to get the ratio as AD by BD. Okay. So this is left hand side what we have got. Now we are going for the next side. See, AB is over now. We are going to take AC, right? So even when you take AC here, the perpendicular line for the line AC is nothing but DP, correct? So if you rearrange, the same triangle is split, correct? Now we see area of triangle DEA, right? Or AED is nothing but what? Base is AE, height is DP. Okay. Now here also height is DP only. And but the base is what? EC. So EC is here, correct? And AE is here. DP is a perpendicular height for both the triangle ADE as well as triangle CED. Okay. Now again you can closely observe here we have half and half which we can cancel, as well as there is a DP and DP which is a common height for both the triangles, that also we can cancel. So when you cancel these two, so what is left? AE by EC, which is our right hand side. Okay. But even though we have got left and right hand side, we cannot tell them as directly equal. Why? Because when you closely observe the ratios, here numerator is EDE and here numerator is AED. That means these two are the same triangles. But when you come to denominator, okay, when you come to denominator, you can see that this is BDE triangle and CED triangle. They are the two different triangles, correct? But in the numerator, it is representing the same triangle. That means the numerator is already equal. But now we have to make denominator equal. Okay. For that we are going to use the concept of what? Think over. See what diagram I have done. See triangle DEB and triangle DEC. They are on the same base D. Correct. So here D is the common base. And this parallel line BC what you are saying, and those two triangles are between the parallel lines. Okay. So whenever the triangles which are on the same base, here is D and D, are between the same parallels, that is D and BC, then their height remains the same, correct? Okay, if you take a parallel line anywhere between the parallel lines, the distance between those two parallel lines remains same. That means height remains same. And here both the triangles are on the same base. So since the triangles are on the same base and between the same parallel lines, what we can say, their areas are equal. So what is the reason? Triangle BD and CD are on the same base DE and they are between the same parallel lines, that is D and BC. So that means their base and height are same. When the base and height are same, the area of the triangle remains the same. So that's why area of BD is equal to area of CD. Now equation 1, 2 and 3, what we have proved now, in from the beginning we already knew the numerators are equal, correct? Now by equation 3, what we have got, the denominators are equal. That means what? This entire ratios are equal. Therefore, we are taking equation 1, equation 2 and equation 3 together, and our result will be AD by DB equal to AE by EC. Okay, this is the theorem. So hence this theorem is. Thank you.